This Python code imports packages for data handling and visualization tasks. These include datatimer, which manipulates dates and times, NumPy for scientific computing, pandas for data manipulation and analysis, and matplotlib, pyplot for creating visualizations. This prepares an environment for working with data. The provided Python code aims to prepare and analyze financial data by using several functions. These functions include preproas, which prepares the data for analysis by formatting it with specific columns and calculating a normalized return and daily return. Strategion, which evaluates trading strategies by looping over the data and recording daily returns for rows with a predicted value of 1 and cap-ending none values for other rows. A strategy 2 and trend strategy, which enter and exit trades based on different columns in the data and record daily returns accordingly. A get Sharpe ratio, which calculates the risk-adjusted return using the provided data and the standard deviation. The code ultimately aims to assess the performance of these strategies by calculating the Sharpe ratio. This code uses Python and the pandas library to import data from a SQL file named daily. Test. The SCP parameter is used to specify the comma delimiter in the file, resulting in a data frame called n with the data organized in columns separated by commas. The code achieves the specific tasks. This piece of code conducts the following tasks. 1. It takes a subset of elements, with index 1856 to 2307, from a dataset called in and saves it as inconj. 2. The preproas function is then applied to inconj and the resulting data is stored in inconj. 3. An adjusted subset of n is created by selecting elements from index 1857 to 2308, and it is saved as inconattempts. 4. The preproas function is applied again to inconattempts. 5. Another subset is obtained from n, with only the figures feature column from index 1856 to 2307, and combined with the preproast incon into a list called inconatest. 6. Finally, the gypt conach function from the pandas library is used to merge the items in inconatest along the columns axis 1, resulting in a new data frame named inconatest with the preproast data and the figures feature included. The code is utilizing the tail method on an object called inconatempts. This method is commonly used with data frame objects in the pandas library of Python. It allows for the selection and retrieval of the last few rows of a data frame, with a default of 5 rows. If inconattempt is a data frame, the snippet would be retrieving the last 5 rows for further use or examination. Alternatively, adding an argument within the method, such as taons, would retrieve the last n rows instead of the default 5. This Python code creates a list, to be entold rows, by iterating through a data frame named incon and extracting certain elements from it. The list contains values from the daily return column of each row. This may be used for additional analysis, such as determining the cumulative return of a Boolean hold strategy. The data structure being used is most likely a data frame, indicated by the presence of the titleRows method from the pandas library. This piece of code in Python takes a list or array called bnholdRows and performs financial computations on it. It converts the list or array into a NumPy array of floating point numbers and proceeds to calculate the Sharpe ratio, a measure of risk-adjusted return. The calculation involves dividing the average value of the array by its standard deviation, while disregarding any non-values that may be present. The resulting Sharpe ratio is then saved in the variable bnholdSharpe. The code reads a CV file called bilsum_first_half CV in a data directory, containing data from a bidirectional Wilson model. It then removes the last 5 rows and displays the remaining rows, providing a view of the trimmed data frame. The given code converts categorical string labels to numerical values in 2 columns of a data frame, possibly named Wilson_prediction. The transformation is achieved by mapping no change down and up to 0, 1, and 1 respectively. This is done for both the true values and predicted values columns, potentially to facilitate numerical calculations for tasks such as evaluating the performance of a machine learning model. This Python code snippet processes data, potentially for time series analysis or machine learning using an Wilson model. 1. Inconattempt preproas inconattempt for preprocessing function is applied to the data in inconattempt, which may involve normalizing, filling missing values, or other preparatory transformations before inputting the data into a model. 2. Wilson_prediction set into inconattempt. Index the predictions from the LSEM model in LSEM prediction or modified so their index matches in Tempus. Index alignment is important for comparing or combining datasets to ensure correct data matching. 3. LSEM prediction date new on attempt. Thelo, 0, values a new or replaced column. Date is created in the LSEM prediction data frame using values from the first column of attempt. Values extracts data values as an array from Thelo, 0, which selects all rows and the first column. 4. LSEM prediction head. The head method is used to view the first 5 rows of LSEM predictions, including the newly added date column and matching indices, often for verification purposes after previous operations. The code adds a new column called daily return to a data frame named LSEM prediction. The values for this column were taken from the daily return column of another data frame called temp. The updated LSEM prediction data frame is then displayed to verify the changes. This snippet uses Python and the pandas library to load a C file. In first half, Leet from a directory named data and store its contents in a data frame called prediction. Certain rows are then removed from the data frame, potentially for formatting or analysis purposes, and the first 5 rows are displayed using the head method. The snippet's objective is to load and modify a dataset, then show a preview of the remaining data. This section of code uses Python to convert categorical labels to numerical values in a data frame named prediction. It focuses on the column's true values and predicted values, replacing no change with 0, down with 1, and up with 1. This step prepares the data for further analysis or use in a machine learning model that requires numeric input. The code performs 4 main actions applying a preprocessing function to a data frame, setting the index of another data frame to match the first, adding a new column using values from the first column, and displaying the last few rows of the updated data frame to visually verify the changes. This Python code is manipulating a pandas data frame, which is a table-like data structure used to organize data. It transfers data from one data frame to another by adding a new column and then displaying the top few rows of the updated data frame to check the changes. A predefined strategy is applied to predictions from a convolutional neural network CNN in Python code. The output is 2 results, nrostone and ncone, with the latter potentially being an NumPy array of numerical data for further analysis. The get_sharp ratio function is then used with ncone as an input, which calculates a commonly used finance measure to evaluate risk-adjusted returns. A message is then printed with the calculated Sharpe ratio value for the CNN strategy 1, providing an assessment of the investment strategy's performance based on the CNN's predictions. A Python code snippet is used to call the function strategy2 with the parameter prediction, and its outputs are assigned to the variables cross2 and nc2. Although strategy2 is not explicitly explained, its name suggests that it applies a trading or analysis strategy to the provided prediction data. The function get_sharp ratio is then called, using nc2 as an input, which is likely intended to calculate the risk-adjusted return for the investment. The code prints a statement to the console displaying the Sharpe ratio for the results obtained by applying strategy 2 on the prediction. This snippet executes an investment strategy on the predictions and assesses its performance based on the Sharpe ratio. This code uses the pandas library to handle CV data. It first loads a CV file called datas first half into a data frame named prediction using the threads function. The file is expected to be in the data directory. Next, the code slices the data frame to remove the first 4 rows and the last 6 rows. The tail method is then used to retrieve the last 5 rows for checking or display. This process is a common way to process a CV file loading, trimming and displaying the resulting data. This code transforms the categorical values of a prediction data frame to numerical values by mapping no change down and up to 0, 1, and 1 respectively. This will make it easier to analyze the data and use it in algorithms that require numerical input. This Python code performs data processing tasks on 2 pandas data frames, attempts and prediction. The first task involves calling the preprocess function on attempts and reassigning the output to attempt. Next, the index of attempt is used to set the index of predictions, aligning the 2 data frames. The code then creates a new date column in prediction using the values from the first column of attempt. Finally, the first few rows of prediction are displayed using the shed method for visual inspection. This code effectively transforms and merges data from the two data frames, focusing on aligning indices and transferring date values before displaying a preview of the resulting data frame. The code snippet adds a new column key called daily return to a dataframe dictionary named prediction. The values for this column are copied from ncontem's existing column key daily return. This modification can be viewed by displaying the first 5 rows of prediction using the head method commonly used in pandas. This is typically done to verify changes or quickly check the data structure. This code uses Python to run a trading or investment strategy called strategion with an input called prediction. The strategy returns 2 values, saved as surostone and centpone. The purpose of strategion is unclear, but it likely processes predictions and computes a trading-related metric. After running, the code prints a message featuring a Sharpe ratio calculation for using strategion results. The function getSharpe ratio uses centpone as an input, suggesting it represents financial returns. The Sharpe ratio measures the investment's performance considering its risk. To summarize, the code snippet implements strategion, then calculates and displays the Sharpe ratio using the strategy output. This code snippet uses Python to call the strategy2 function and save its 2 return values into the variables stros2 and smp2. Then, it prints a message displaying the Sharpe ratio for using strategy2. By passing smp2 to the getSharpe ratio function, the Sharpe ratio is a measure of investment performance and risk adjustment, providing an indication of excess return per risk unit. It is commonly used for comparing portfolio risk-return characteristics. The output will show the Sharpe ratio for when implementing strategy2. The following code in Python performs these actions. 1. Reads a CD file called build.autonoder's first half. In the data directory and saves the data in a pandas data frame as partitioned. 2. Removes the last 6 rows in the data frame, shortening the dataset. 3. Displays the last 5 rows of the updated data frame for confirmation or review of the row removal process. This Python code converts string values in the columns true values and predicted values of the data structure called prediction by using the shmap function. The string values no change, down, and up were transformed into numerical representations of 0, 1, and 1 respectively. This encoding process allows for the manipulation of categorical variables in numerical-based algorithms or models. This Python code snippet applies various operations to data, most likely stored in pandas data frames. First, the ncontemp data frame is passed to a prediction function to clean and preprocess the data. Then, the prediction data frame is modified by setting its index to match the modified ncontemp data frame, giving them the same row labels. The prediction data frame also gains a new column called date with values from the first column of ncontemp. The head method is then used to preview the first few rows of the updated prediction data frame. This Python code takes the values from the daily return column in the data frame ncontemp and adds them to a new column called daily return in the prediction data frame. It then displays the first 5 rows of the updated data frame. Essentially, it copies and previews the daily return data from one dataset to another. This code involves a financial trading strategy that uses the Sharpe ratio to measure performance compared to a risk-free asset. The strategion function processes predictions from a bidirectional autoencoder, returning a numerical representation likely in the form of a numpy array. The calculated Sharpe ratio for this strategy is then printed. This Python code runs a function called strategy2 with an input called prediction, which is related to finance. The function returns 2 values and saves them as gros2 and gtomp2. Then, a message is printed to the console which includes the string Sharpe ratio for bidirectional autoencoder using strategy2 is followed by the result of the function getSharpe ratio applied to gtomp2. The Sharpe ratio measures an investment's return compared to its risk, and is commonly used in the financial world. Overall, this code calculates and displays the Sharpe ratio for a financial strategy. This Python snippet reads a CD file and renames columns in a data frame before modifying it by removing certain rows. The updated data frame is then stored under the original variable name. This Python code is modifying a data structure called prediction, possibly a pandas data frame. It updates the columns true values and predicted values by converting their text labels to numerical values. The labels no change, down, and up are mapped to 0, 1, and 1 respectively. This process is commonly used to prepare data for machine learning models or numerical analysis. This is Python code that works with pandas data frames. The index of JWavNet prediction is set to match the index of IncoNetTemp. A new column called date is added to JWavNet prediction using data from IncoNetTemp. And the head method is used to preview the modified data frame. This synchronizes the data frames and adds a date column. The snippet ends with displaying the top rows of the modified data frame. The code takes values from a data frame column called daily return and adds them as a new column called daily return to a different data frame. JWavNet prediction. The code then displays the first few rows of the updated JWavNet prediction data frame. The code creates a dictionary called strategies with an initial value of IncoNetTemp. It then assigns new key value pairs to the dictionary, with each key representing a specific strategy and its associated variable containing relevant data or results. These keys may correspond to different algorithmic trading strategies or machine learning models, while the values may include outcomes, configurations, or datasets related to each strategy. This code snippet uses the head method to retrieve the first 5 rows of an object called strategies, typically associated with pandas data structures. This is a useful way to quickly view a few entries of the data frame or series without the entire dataset. If a strategy has less than 5 rows, all available rows will be returned. The provided Python code snippet modifies the strategies data frame by renaming a column and removing specific columns. The renamed column, daily return, is changed to behold and the data frame's indices are converted to strings. The code then removes the columns open, norm return, allocation, position, and close using the drop method. The head method is then used to view the first few rows of the modified strategies data frame. The output of this snippet is not explicitly shown as it is not assigned to a variable or printed. The provided Python code works with a variable called strategies, likely a pandas data frame. First, strategies. Fillna0 replaces any missing values with zeros using the fillna function. Next, strategies. Head displays the first few rows of the data frame for a quick check, with the option to adjust the number of rows shown. This code essentially cleans the data by replacing missing values and showing the initial portion of the data frame for inspection. The provided code updates values in a dictionary called strategies. Each key in the dictionary, which appears to represent various trading strategies, is replaced with the cumulative sum of its original value. This type of operation is commonly used in financial calculations to track performance over time. It can be assumed that the code is tracking the results of multiple trading strategies and the cumulative sum represents a metric associated with each one. After execution, the keys in this strategies dictionary now reference their cumulative sums. The following Python code uses an object called plotStrategiezone to save a plot or graph as an image file with the name period in a strategion. Ping. The getFigure method retrieves the associated figure object, and the saveFig method is utilized to save it in ping format. This code captures the strategy's visual representations using a saveFig method, most likely generated with Matplotlib. It retrieves the plotted figure from the variable plotStrategies2 and then uses saveFig to convert it to an image file named period in a strategy2. Ping. The resulting image is typically saved in the current working directory, unless otherwise specified.